Now let us see another problem type which is based on graphs. Right, so now let us see this question. Given below are two statements. Statement 1, area under velocity time graph gives the distance traveled by the body in a given time. And statement 2 is area under acceleration time graph is equals to the change in velocity in a given time. So in the light of the given statement, choose the correct answer from the option given below. Right, so if you look at the statement 1, it says if we have a velocity time graph, okay, suppose this is the velocity time graph, the area under this graph gives us the distance traveled, right? So it will be distance traveled if the particle is not changing its direction while moving. But if the particle is changing its direction, then it should give us the displacement, right, of the particle. So statement 1 is not completely correct, it is incorrect. So the right statement would be like the area under velocity time graph gives us the displacement covered by the particle. Now statement 2, area under acceleration time graph is equals to change in velocity in a given time. So if I draw acceleration time graph, let us say this is acceleration time graph, and if I find the area, so if I take a small strip, this is dt, and so we can say the area will be integral of a dt, and integral of a dt is nothing but integral of dv, which is change in velocity. So v final minus v initial. So that gives us the change in velocity. So statement 2 is correct. So the right answer should be statement 1 is incorrect, statement 2 is correct. So it should be 3.
So before I start solving this, if you're preparing for JEE or NEET and you feel stuck with concepts, strategy, revision planning, or question solving approaches, then you can check out Pracbee. At Pracbee, students can book personalized one-to-one mentorship sessions with experienced mentors to get individual guidance based on their own strengths and weaknesses. Now with that said, let's get into the question and see the smartest way to solve it.
Right, now let us see this question based on graphs. The position time graph for two students A and B returning from school to their homes are shown in the figure. Right, so if you look at the graph for A, it starts this graph starts from the origin, and we can also see the displacement of A, right, and the time taken by A to reach school. A lives closer to school, okay, and if you look at the displacement of B, we can also see the displacement. Can you see the displacement of B is greater than displacement of A, and the time taken by B is less than the time taken by A. So that is the time taken by B, right? That much. And this is the time taken by A. And if you look at the slope of these two graphs, slope of so B is much more steeper, so we can say the velocity of B is greater than velocity of A. Now let us see the option. So A is given as the A lives closer to the school. Yes, yes, because it has covered less displacement. So A is correct. B lives closer to school. That is incorrect. A takes lesser time to reach home. So A is taking more time. So C is incorrect. A travels faster than B. That is incorrect. B travels faster than A. That is correct. So A and E are the correct statements. So option 1 should be the answer. Right. So let us see this question. From the VT graph shown the ratio of distance to the displacement in 25 seconds of motion. So whenever we have given velocity time graph, the area which is above the time axis will be taken as positive, and the area below the time axis will be taken as negative for displacement. But in case of distance, we have to add both the areas. So let us first find the area above the time axis. So here we have a trapezium. There are two trapezium, right? So for this trapezium, the area will be, let me call this as 1. So A1 will be half sum of parallel side, which will be 5 plus 10. And the distance between parallel side is 10. So it comes out to be 5 times 15, which is 75 meters. And A2, so this area will be A2. Again, half times sum of parallel side, which is 10 plus 20, and the distance between parallel side is 5, so it will be 15 times 5, so that is again 75 meters. Now the area of this triangle, which is 3, so it will be half base into height. Height is 20, so that will be 50 meters. And let us find this area also below the on the time axis. So this is 4, so A4 is half, base is 20, base is 5 and height is 20, so that will be 50. So if we want to find the ratio of distance to displacement, so distance to displacement, so distance will be A1 plus A2 plus A3 plus A4, and displacement will be A1 plus A2 plus A3 minus A4. So it comes out to be 75 plus 75 plus 50 plus 50 divided by 75 plus 75 plus 50 minus 50. So that will get cancelled out. So in the numerator we have 150, 250, and in the denominator we have 150. So that will be 5 by 3. So 5:3 should be the answer. Option 3 is the right answer. Now let us see this question. A bullet is shot vertically downward with an initial velocity of 100 meters per second from a certain height. With 10 seconds, the bullet reaches the ground and instantaneously come to rest due to the perfectly inelastic collision. The velocity time curve for the total time. Okay, right. So the velocity time curve for the total time t equals to 20 seconds. So we know that after 10-second ball will come to rest, and initial velocity was 10. So its speed will keeps on increasing. It is going down, right? So we can use elimination. So if you look at option B, here the speed is decreasing, so option B is incorrect because it should increase up to 10 seconds. So here the initial velocity is 0, that is incorrect. We have thrown ball with certain velocity. Here again it slows down, so D is incorrect. So the correct answer should be option A, where first speed increases uniformly and then it becomes 0, and again it is increasing the negative x direction in negative y direction. So here we have considered upward direction as positive. So option A is the most appropriate answer. Now let us this question. The position, velocity and acceleration of a particle moving with constant acceleration can be represented by. So in when the particle is moving with constant acceleration, then acceleration time graph, like acceleration is constant in uniform accelerated motion. So if you look at all the options, we have acceleration as constant, right? And velocity time graph will be linear. It should be a straight line. And if it is accelerating, the speed should increase. So we can say this one is incorrect. This one is incorrect because it should be a linear graph. Now let us see. Now we have to check for the position time graph. In case of a uniform accelerated motion, position time graph is parabolic. So option 2 is the correct answer. Now let us see this question. The velocity displacement graph of a particle is shown in the figure. It's a straight line, right? And the acceleration displacement graph of the same particle will be. So what we can do, let us first write down the equation of this straight line. So it will be v by v naught plus x by x naught equals to 1. So I have used like intercept form, and we have to find acceleration. So let us differentiate this. So it can be written as, if I differentiate this, v will become a, so a by v naught, and x will become v by x naught, and 1 will become 0. Now we can substitute v from the first equation. So v is nothing but 1 minus x by x naught times v naught. So let us substitute in this equation. So a by v naught plus 1 by x naught times, and we have v naught 1 minus x by x naught equals to 0. And from this, a by v naught can be written as v naught by x naught square times x minus v naught by x naught. Okay, now let us take this v naught on the other side. So it is a straight line. Can you see? This is the slope, that is the y-intercept, and y-intercept is negative and the slope is positive. So option 3 is the right answer. Now let us see this question. The velocity displacement graph describing the motion of a bicycle is shown in the figure, and the acceleration displacement graph we have to calculate, we have to find. Okay, right. So from this we know that acceleration is v dv by dx, right? So can you see, if from 0 to 200 meters velocity is increasing linearly, so this dv by dx is constant, so that is constant, right? So we can say acceleration will be directly proportional to the velocity. So velocity is increasing linearly, so a should also increase linearly. So option 3 and option 2 are incorrect, where we have a non-linear graph from 0 to 200 meters, right? Now after that velocity becomes constant, so dv, so we can say dv by dx will become 0, so acceleration will become 0, right? So option 1 is the right answer, where first it increases linearly and then it will become 0. So option 1 is the right answer. Now let us see this question. Here we have given two columns. In column 1 we have given xt graphs, in column 2 we have vt graph, and we have to match the columns. So if you look at A, here the slope is continuously increasing, it means the speed is increasing, right? And it looks like a parabolic function, and we know that when x is a parabolic function of time, then the velocity time graph will be linear. So we can say a corresponds to 2. If you look at the b, x is decreasing, right? So x is decreasing, so we can say speed is also decreasing, because the slope is decreasing, right? The steepness of the slope is decreasing. So so if you look at option 4, that is that correctly represent this. So b corresponds to 4. And in C, first we have a linear graph up to a certain time, and then again linear graph. So so from, let me call this instant, from 0 to t1 position is increasing linearly, and so velocity will be constant, and it will be in the positive direction. But after that we have a negative slope, so it will be, velocity will also become negative. So option 3, so C corresponds to 3. Now for D, xt graph is linear, so dx by dt will be constant, so velocity should be constant, so 1. So D corresponds to 1. So let us see the option. So A is 2, B is 4, C is 3. So option 1 is the right answer. Now let us see this question. If the velocity time graph has the shape AMB, what could be the shape of the corresponding acceleration time graph? So AMB, so if you look at AM, we have a negative slope, and we know that dv by dt gives us acceleration. So if dv by dt is negative, so it will be negative acceleration up to a to m, right? So negative acceleration, and after that m to b acceleration, velocity is increasing linearly, it will be a positive acceleration. So option 2 is the right answer. First it is negative and then it becomes positive, and both the cases it is constant, because the velocity time graph is linear. Now let us see this question. The velocity time graph of a body moving in a straight line is given by this graph. The ratio of the distance to the distance traveled by the body in time 0 to 10 seconds. So 0 to 10 seconds we have to calculate. So in order to find, we have done similar question, right, where the displacement, in order to calculate the displacement, the areas which is above the time axis, will have to take them as positive, and the area which is below the time axis we have to take them as negative. So let me name it. So let me call this as area 1, this is 2, this is 3, this is 4. So A1 is, it's a rectangle, so 8 times 2, 16 meters, and A2 will be 2 times 4, 8 meters. A3 will be 4 times 4, that will be 16 meters, and A4 will be 2 times 4, that will be 8 meters. So ratio of distance to displacement, so distance will be nothing but sum of all these areas, A2 plus A1 plus A2 plus A3 plus A4, and displacement will be a1 plus a3 minus a2 minus a4. So it comes out to be 16 plus 8 plus 16 plus 8 divided by a1 plus a3, that will be 16 plus 16 minus 8 minus 8. So the numerator will be what? It will be 48, and the denominator will be 32 minus 16, that will be 16. So it is 3. So 3:1. And we have to find displacement to distance. So displacement to distance will be 1:3. So option 4 is the right answer.